So this is an example presentation on what I would like your actual presentations to look like. So I'm giving you an example so that you can pretty much pattern it for when you do it for real. I chose flexibility, and you're going to see a fair amount of recycling from the lecture, but I did that on purpose because I didn't want to use up another molecule or another gene. I wanted to allow you to have a chance to use those. So the first thing that I would like you to include is a physical assessment. And you can see here that the physical assessment that I chose for flexibility was the traditional sit and reach. And I've gone through and I've included a step-by-step checklist, if you will, of how to perform the traditional sit and reach. When you do this in your presentation, what I would like for you to do is to go ahead and make copies for your classmates, and then what they can do is they can put them in their binder, and then at the end of the semester you'll have a nice little compilation of a couple of different checklists of what you can do for, say, flexibility measurements. And you'll have a number of checklists for muscular strength assessments and um, anaerobic assessments and so on. So I'm not going to go through this step by step, but what you would do during your presentation is you would take us through the assessment, essentially step by step, and you would do a demonstration. The next thing that I would like you to include is a summary article using a molecule that you have chosen that relates to both exercise as well as the fitness component. So in this case, it's a study that I found using hydroxyproline as the article, and they went through and they had individuals complete a flexibility protocol. So they had 60 males between the ages of 15 and 20 years old, and they partitioned them into groups. I'm guessing groups of 15. So there was a control group that didn't do anything. There was a group that they called stretching, and basically what they had them do was trunk flexion for 5 seconds at a time, and they did 3 repetitions of this. They had a static stretching group, which is different from the stretching group basically due to the amount of time that they carried out the stretch. So in the static stretch, they had them carried out for 15 seconds. And then they also had a PNF group where they did alternating 8 seconds of contraction relaxation. They did this 3 times, and also with trunk flexion. And basically for this portion of the article, and they looked at a number of different things, but I am focusing in on the hydroxyproline because that's our molecule of interest. And they compared control groups, the control group to each of the 3 different stretching groups. And what we're interested in is the p-value there. Basically it tells us that there is no difference. And then they also compared the groups amongst each other, and they also found no difference. And I'm going to guess it's because the stretching protocol was probably not strenuous enough in order to see an acute change. The next thing that I would like for you to do is to include a physiological link or rationale as to why you can utilize this particular molecule as a reflection of the fitness component. So hydroxyproline, it's an amino acid, and it's found in collagen, and it has a particular role in stability. So when there is sharp twisting of the collagen helix, this maintains its shape, maintains its structure and stability. So when you use your muscles, either through contraction or flexibility, it's thought that an adaptation process occurs, and the basically what happens that allows you to adapt to the stress of the contraction or the mechanical loading found in flexibility is reflected in a rise in hydroxyproline concentration, and that you can measure this either in urine, as you'll see when you watch the video associated with their flexibility chapter, or in uh, another substance, such as in the blood or as in the saliva. The next thing that I would like you to include is how you actually carry out the molecular assessment. And I realize that a lot of you don't have experience with molecular techniques, but I think it's a good idea to be able to find an assay and at least take us through step by step how you would perform the assay. Because my guess is that as you progress through your master's degree, through your PhD degree, that you will more than likely do this to some extent. So our example of this molecular assessment is the ClinRep urinary kit, and it occurs in 4 steps. The first one is hydrolysis, where the substance that you're using is urine. You add it to an international standard, as well as hydrochloric acid. You can see the quantities there. You incubate it for 16 hours at 95 degrees Celsius. The next step is derivatization, where you're adding 100 microliters of that sample to reagents A and reagents B and C. Then you take that sample and add it to reagent D. And then you take that sample mixture and add it to reagent E, incubate it for 10 minutes at 70 degrees Celsius. Then the next phase is dilution, where you add it to a mobile phase. And then finally, you analyze it by injecting 20 microliters into a high-performance liquid chromatography. And I'm including this so that you're aware of usual ranges. So you can see the range there for 18 to 21-year-olds is 13 to 28 milligrams per meter squared for a 24-hour period. And then you can also see what the range is for 22 to 55-year-olds. And there are a couple of representative chromatograms down at the bottom there that is important for us in order to determine what the concentration actually is. The next thing that I would like you to include in your presentation is a summary of a gene article. And the gene that we're using is collagen 1A1. You can see the title. It's called Inflammation and Mechanical Stretch Promote Aortic Stiffening and Hypertension Through Activation of P38 and Mitogen Activated Protein Kinase. If you wanted to, you could look up this article. There was a lot going on, and I focused in specifically on the stretching component. Basically what they did is they had different types of mice, and they dissected the aortic fibroblasts out of these mice. Then they put them on a plate and exposed them to either a 5% stretch, which was equivalent to a normal blood pressure, or a 10% stretch, which was associated with hypertension. And you can take a look at the table down there. Again, there's a lot going on, but I want you to focus in on the red brackets. And essentially what happens here is that the 10% stretch elevated the expression of this collagen A1A gene significantly above the control. The last thing that I would like you to include is the physiological link and basically a justification or a rationale as to how you can utilize this gene to reflect what is happening with the physiological or with the fitness parameter that we're interested in. So since we're doing stretch or flexibility, we're going to say that a mechanical load or a stretch is applied to a cell, and that this mechanical stretch induces mediators to bind with factors that span the membrane. And this essentially takes it from a mechanical signal into a more of a chemical signal. And that then on the inside of the cell, there is a signal that's induced. And it's an intracellular signaling pathway. And the eventual target is in the nucleus at the collagen A1A gene that then becomes transcribed, and you generate messenger RNA, and eventually the end result is that you increase the amount of collagen in the extracellular space. So this is an example of what I would like your presentations to look like. You're going to put a fair amount of work into these, and there are 6 components worth 1% each. So that's 6% for this particular presentation. And you're going to end up doing 5 of these presentations, so 1 for every fitness component that we're going to cover. So it's going to represent a pretty large chunk of your grade. So I would like for you to spend some good time on it. However, when you actually give the presentation, there are going to be a number of other students that are presenting the same day you are. You don't have half an hour or an hour to show off all your work. So I would like for you to keep it to probably within the 8 to maybe 12-minute range. Anything longer than that is probably pushing it. So that means that you should probably put your presentation together beforehand, and then also practice a number of times so you have a good idea of how long it's actually going to take.